Hey there, me again. How's the weather where you're at? This behind me? It's bogus. Green screen. Hey, been a little tied up here, so I finally got some free time. I'm going to make a quick little announcement here. If you came here from my old channel, which is now my personal channel, you will probably have no problem finding comments from people on various videos over there asking me if I would ever consider releasing the software that I wrote that controls the greenhouse and pellet stove, the entire climate control stuff. Back then, I couldn't do it because that software was, well, basically static built to work with my existing setup. It wouldn't have worked for anybody else unless they had the exact same setup that I have. So I never did release it, and I constantly responded to those comments saying so. Well, with all of the blizzards and winter storms that we've had here in Nebraska since the middle of December, I've finally had time to do something that I've been wanting to do for a long time, but I just never had the time to do it. And that was to rewrite that software from scratch and make it completely open-ended. And not only that, it's completely open source and available on GitHub. It's called Climate Czar, and it is originally targeted to work with a desktop computer or a laptop, something like that. However, it does also work to a degree on cell phones, meaning the administrative functions of the website or the software for adding controllers, sensors, things like that. You're not going to do it on a cell phone. Everything would just be too cramped on your screen to do so. But as far as doing basic status, observation, stuff like that, it works just fine. I have two cell phones here. Aside from the desktop view, it also has a condensed basic mobile view for low bandwidth connections, weak phones. But for example, if the camera will focus on this, hard telling, that is the desktop view that is shrunken down to display on a cell phone. And as you can see, if I scroll down the screen, if the camera will pick it up, I'm not sure, I can't tell. It's got buttons on there so you can turn things on and off from your phone if you want to. Let me get my other phone here. And this is the basic mobile view, very stripped down, not real pretty, but it still has the same level of functionality. If you want to, you can turn things on and off as needed. So while it's not originally written for a cell phone or any mobile device, it will work to a degree. If a mobile app mobile app developer wants to contact me about making a mobile version of this, I will happily work with them to create an API for their mobile app to talk to. But as far as writing mobile apps, that's just not my thing, because I really don't want to pay Apple $100 a year for a code signing certificate that I'm probably going to use once. And have to pay, even though it's open source, I still have to pay them to put it in their app store. And Google is no better when it comes to Android apps and their app store. You just got to jump through a whole bunch of hoops. That's not my thing. I don't have time to become a mobile app developer. Aside from the expense and other circus tricks, I just don't have time for it. But I'm going to go through the software on my laptop. I'll do a screen recording while I'm doing this and show you the various features. Like I said, it's not brand specific as far as sensors and controllers, output switches, some people might call it. Anything that you can talk to via the command line on a Mac or a Linux system, it'll work on there, or it'll work to communicate with it. It could also be a Raspberry Pi computer with devices connected directly to the GPIO bus, or could be Wi-Fi devices. As long as you can talk to it from the command line to get a reading from it, or if it's a switch, toggle it on and off, the Climate Czar software is 100% open-ended, open source. It'll work with anything. What else? I can't really think of anything else specific. Oh yeah, the name Climate Czar. I had to name it something. GitHub wouldn't let me put the software up there without giving it a name. So I'm just going, what would be somewhat related to what the software does and something semi-hilarious at the same time, because people always remember funny stuff. So if I give the software a funny name, hey, chances are people are going to remember it. I won't have to constantly tell them what the name is. So that's about it for this intro. I'll be right back, and I will have the laptop fired up and show you the software in action, talking to the devices in my greenhouse right now, and show you how to configure things like that. Just show you all the bells and whistles. It'll probably come in handy for a lot of people, especially since it's free. It'll run on any computer, whether it's a Raspberry Pi or one of those little $90 mini PCs that you can get off of Amazon, or if you want to go a little crazy and get an i7 based Intel NUC, hey, that's even better yet. But there's no limitations to it. You could have as many sensors, output switches as you want. It just, I think I finally hit the point where I have something that will work for everybody, and I've also enhanced my own capabilities with my own system at the same time. So anyway, I'll be right back in just a few seconds. All right? Okay, I'm back. What a cold day out here. Good God. -10 for a high. Anywho, I got my laptop here, and it's a System 76. I'm a Linux fan, and you'll see here that a Linux laptop is no more complicated to operate than a Windows laptop or a MacBook. Anywho, as you can see here, this is the front page of the Climate Czar system. You might have thought that I misspoke earlier when I said that it was a website. It's not. The system is built around WordPress for the user interface. I custom built a WordPress plugin to do all of this stuff that it needs to do. Underneath of this is there are two messaging systems, two loops that run in the background on the machine, the server machine. And don't be alarmed by the word server. It doesn't have to be a big monstrosity. Like I said, it'll run on a Raspberry Pi computer or a micro PC. But there's two loops in the background. One that reads the input sensors, whether it's temperature, switches, a pH probe, whatever it is, any variable value sensor. And it can also be a standard on-off switch. But there's one loop in the background that reads all of that and updates a database on the system. The other loop is the one that reads the database and then writes things out, sends commands out to your output switches to turn things on and off. So, and each one of those, they fire every 15 seconds. So that you might think there's some lag in there, but it's really nothing to even concern yourself about. 15 seconds. A temperature detector detects that it dropped to 40 degrees. It needs to turn on a heater in the greenhouse. I think you can wait 15 seconds without causing any problems before that heater turns on. But that's how it works. So there's two loops running in the background to read inputs and write outputs. And the WordPress system and the plugin just provides a user interface into that. Now, as you can see on this page here, the home page, up here above my mouse pointer, these are the input sensors or input devices. So we have one reading the greenhouse east temperature, west temperature, and then the one over here that says average. That's exactly what it is. It's the average of the two. Those sensors can be reading two totally different values at the same time and wildly different from each other. So it's not really smart to make decisions based off of just one of those. I mean, it's the entire greenhouse. You should make decisions based on the average of those two temperatures. And then we have a humidity detector, hydronic boiler. That's the pellet stove boiler that boils the water, pumps it through that coil that's in the fish tank. I made sure to specify hydronic, which is, when you have radiant floor heating in your house, that's a hydronic system. I had a lot of people thinking that I'm boiling my fish tank water, and no, that's not the case. If you were to try that, you would plug up your boiler tube inside of the pellet stove in no time flat. The protein that's in aquaponics water from all the fish waste, it doesn't like heat, and it'll plug up like same as if you're dumping protein down your kitchen drain. It'll plug up the pipes. So that's why we do it with a hydronic boiler. Then we have the fish tank temperature. Underneath that, the daylight extension scheduler. Those are the lights in the greenhouse. They're LED parking lot lights at 3000 K color temperature. They are there to simulate the pink sky in the morning and the evening in the summertime, and they get AC power at, according to this schedule, at 6 a.m. and the power gets cut off at 9 p.m. When it gets so bright during the day, those lights will turn themselves off because they have their own built-in photo sensor. Next to that, we have a master power switch for the pellet stove to turn it on and off. And then over here, the statistics. Now, the pellet stove itself, the main board burned out. It went south. I ended up having to write my own code that runs on a Raspberry Pi that controls 4 relays. One to turn the combustion blower and bottom auger on and off. One to turn the igniter on and off. One to turn the room air blower on and off, which kicks on once the stove gets up to temperature. And one to control the top auger, which is actually the feed. Now, if you're using a custom-built pellet stove or anything like that, that only has one auger, it would connect to the relay for the top auger. That's just the feed auger. So those up there, those 9 up top, are input devices. Let me scroll this down. Down on the bottom, these are the actual output switches. So there's one for the exhaust fans, the kerosene blast heater, pellet stove to switch into high burn mode, 3 electric heaters in the fish tanks just in case the pellet stove goes out, and then one for the greenhouse lights. Now, as you can see, each one of those switches has 3 buttons on it. One is, the on button, which turns it on and holds it on. Doesn't matter what its input sensor says. So like in the case of the green or the exhaust fans, they monitor the greenhouse average temperature. They kick on at 95 degrees and then kick off when it drops to 85. Now I could just as easily turn those on and make them stay on no matter what this temperature is. I could also click on the off button. I'll go ahead and do that since nothing's happening. And they are disabled. They will never turn on. And if I want to go back into automatic mode, I click on the auto button. And where it says switch mode, yep, it just switched to automatic again. So these are the things that I'm saying that you can control from a cell phone screen. And oh, by the way, I looked at that video clip. Sorry, too much glare. You really can't see what's going on or any detail in the screen. I would suggest going to the live demo. You can view the system on your own computer or cell phone if you want. If you want to switch the cell phone into basic mode, you click on a cell phone, you'd have a menu button, but you click on your menu button, go to management, and down here where it says set basic mobile view, I'll do it on this, and it'll switch it into basic mode for a cell phone. Set it back to desktop view, and there you go. So as you can see here, we'll go back down to this. Like, you'll notice that the pellet stove high burn mode and all of the electric heaters in the fish tanks, they follow one temperature sensor that reads, one of the fish tanks. So you could have as many output switches connected to an input device as you want. And by the same token, you could do the same thing by either using an average, have a whole bunch of input sensors and then run them into an average and have that control things. There are other types of things such as computer logic gates built into it, like an AND gate, OR gate, NOT gate. So let's see, an AND gate, I'll pull that up really. I have a group here. So on an AND gate, if these three up here are all on, this one down here will read on. But if only one of them is turned on, this will never turn on. So an AND gate means this and that all have to be on. See how the third one turned on, but we still have an off down here? If they were all on, that would turn on. Counterpart to that is a NOT gate. If all of these three are not on, if they're off, this will actually turn on. So it's the inverse of the other one. And then we also have an OR gate. Oops. So any one of these. So if this or this or this is turned on, this will be on. And any combination of them. All three of them could be on and this will be on, but it only requires one of them to be on. So there's a lot of uses for things like that. Say, for example, you had flood detectors in a building. You don't want all three of them to have to be reading a flood to have an alarm, so you would use an OR gate. You would have all of these flood detectors feeding an OR gate, and then this would connect to an output switch that would send an alarm or do whatever. Let's see what else. We have web console switches, so they don't use a sensor. You can actually just control these. So these would feed an output switch, and you can turn them on and off from the web console. And then raw text output. So that's anything that just receives raw text and you want to put it in your dashboard. So I created a little script to show the CPU information. Let's see, public server IP information, weather statistics. No? I thought I had one for weather in here. Nope, guess I don't. But like my IP or internet provider is Spectrum. This tells me everything about my IP address, and it comes from a website that provides that. So it's nothing built into the Climate Czar software. It's just a script that pulls this. And that's how the Climate Czar works. It uses scripts for everything, either scripts or just command line tools. I'll go to manage devices here. And I'll go back to my main default group and see, yes, you can have all your devices in different groups. So in theory, what a person could do, say that you had 3 greenhouses in your backyard. Each one of them could be on a separate group, so you could just flip between them, not be all confused by having 30 devices on your screen all at once. You could just have 10 for this one, 10 for that one, 10 for that one. So yes, I put groups in there for that very reason. But get that off the screen, Larry. My daylight extension scheduler. So here's how you can configure things. This is just a timer, and as you can see down here, it says it turns on at 6 a.m. and off at 9 p.m. Have to do this in 24-hour format. Let's see, fish tank sensor. So there's a command that talks to a Raspberry Pi in the greenhouse that has temperature sensors on it. Now, you don't have to use that. You could use any IP thermometer. They sell those on Amazon. They sell them everywhere. They're IP network thermometers, and you can talk to them with a script. But you have options to show it in the dashboard, which position, because they just read from left to right and recycle. So this is the 6th one, which would be all the way to the right 2nd row, since I'm only displaying 3 on my screen. Group assignment, we'll get to this part later, the graph color. And if you notice those indicators in the dashboard, they show different colors and a number, so you can set the crossover points for that. Pellet stove, let's see, pellet stove statistics. So like when you look at this over here, these statistics, this is one of those raw text sensors. It's just pulling data from the Raspberry Pi that's running the pellet stove. And let me point out, I'm going to make that available too, so people could use something as simple as a Raspberry Pi Zero, install all that on there and interface it with any pellet stove under the sun, or even a custom built one, because if you look at some of my previous videos on my old channel, I built my own pellet stove, my very first one that I used for heating fish tanks, homemade. So let's go back to those settings again. Statistics. Now this one doesn't use a script. This just uses a standard command line utility in Linux or Mac OS called curl. I heard my furnace kick on. That's going to be loud because I have a oversized furnace for my house. Let's go to management here. We can manage scripts. We can custom make scripts. Like I use Casa TP-Link devices to turn on exhaust fan and blast heater out there. Here's a script, came from GitHub, that is used for turning them on and off. You can use other people's scripts or come up with your own. Here's one command, curl, talks to the Raspberry Pi out there, pulls readings off of it. So you can make your own scripts. There's just umpteen things you can do with this. This is so open-ended, it'll work for anybody in any greenhouse, no matter what kind of equipment you're using. So I'm going to cut this off here. Well, maybe not. We'll go to the graphs. If the furnace kicks on, it kicks on. Yes, we have charts and graphs here. We can see trends over time. Like, let me pull up the hydronic boiler one. We can see what the temperature was at any time. We can do other things such as average temperature of the greenhouse. got up to 60 in there, even though it's minus 10 outside, but that's sunlight for you. And now we're down to, if I can get my mouse on that, maybe not. But it looks like, yeah, we're down to about 45 right now. We can show the device logs. So every minute there is a timestamp in here and a reading. Go over to basic view. This even works for basic devices. The graphs aren't quite as fancy. They're a little, because I had to write that code myself. The other one is a library called Charts.js, a common JavaScript charting library. But since they don't always work on iPhones, iPads, things like that, but they work perfectly fine on a Mac. Don't know what's wrong with iOS. I don't really have time to figure it out either. Like I said, mobile devices are not my thing. You know, I'm not a mobile app developer. But if we go to the boiler one here, we still have it. It's just rendered in a not so fancy, pretty method. But I think that's about it. What I'm going to do is, all right, number one, I'm going to release that Raspberry Pi pellet stove controller as a bundle on the same GitHub page. All that's linked in the description below. So there's going to be that I'm going to release, and then 2 other devices. And if somebody doesn't want to build these, I will happily sell them in an assembled unit. No big deal. But there's going to be that one called a sensor hub, which will have a built-in temperature and humidity sensor, but will also have 16 ports on it that you can either use for, variable value sensors such as temperature sensors, float switches, float position sensors, because they will have an analog to digital input on them. The whole thing is based on an ESP32, which is like an Android on steroids. So I'm going to have that. Oh, and it connects by Wi-Fi, so there's no big deal to making this thing talk to it. And then there's going to be a switching hub, which is going to be the same thing. Has 16 ports on it, but it's for turning solid-state relays on and off, so you can have 2 boxes in the greenhouse that this would talk to. One to read values, from 16 sources. One to control 16 outputs, and you could pile as many of those on as you want. You want 32 inputs and 32 outputs, have 2 of each. So let me see, I'm up to 20 minutes on this second segment. I had 10 on the first one, I believe, so I'm going to cut this off here. Anywho, links in the description to get to the Climate Czar GitHub page. You can download it there. Let me know if you aren't up to the task of building it yourself, building the server. I'll happily do the same thing there. You could either send me your own computer to put it on, or I can order one of those micro PCs off of Amazon. They go for about $100, somewhere in there. Get it set up and just send it to you. All you got to do is connect a cable between it and your router, an Ethernet cable, and you're off to the races. So any questions, put a comment down below, or you can reach me on Twitter. I'll put that down there too. Some people can't seem to get past the anti-spam test on my website, so you can always reach me through Twitter. I'm not on Facebook. I'm on MeWe for other social media, and I intend to put a group together on MeWe for Climate Czar support, so I don't have to maintain a forum on my own website for it. So that's that. I'm going to cut this off here, and we'll see you around next time. Like I said, just post a comment below if you have questions. Take it easy. Bye.